Another Swift in plain English tutorial. Today I'm going to talk about Swift data types. So we have the integer, float, double, bool, string, character, and optional. We're going to quickly gloss over today. So kick things off with the integer. So the integer is pretty much, if you're familiar with any kind of maths, it's just a whole number. So let a of type int. So it's how you cast a type if you want to explicitly say what type you want a variable or a constant to be. So here, you just do this with this colon, and then you say what type you want it to be. So in this case, it'd be an int, which is short for integer, and then that's equal to has to be a whole number. So you can't just do like 1.0 because it's going to get confused. And that in fact is a double or a float, but we'll get into that in a minute. Things to note with integers, like you can have either 32-bit or 64-bit integers, so you can use int32 to explicitly say a 32-bit integer or a 64-bit integer. Another thing to note with the 64 and 32-bit integers, so integer 64 uses a range of 2 to the power 64 plus 1, and it goes in both directions from 0, so that's the actual range, it's not the maximum number it can go to unless it's a uint 64 or a uniform int. And the same with 32. So int 32 is the same as 2 to the power 32 plus 1, and that's the maximum, that is the range of numbers you can use in both directions from 0. You can also have it what's called a uniform integer, which essentially is only positive numbers. So if I said that was -1, it's going to complain because it's saying it's unsigned. And the reason for that is that for 32-bit and 64-bit is only a certain range of numbers. There is a limit. You can't go off to infinity. And then the reason you'd want an unsigned integer is so that you can use all those numbers just on the positive side of 0 and not on the negative side of 0. So yeah, if you needed to access a high number on the positive side, you would use an unsigned integer and not a regular integer. Moving on to floats. Floats are essentially decimals from regular maths. So if they cast it as a float, equals 0.6, for example. That's how you can do like decimals if you want. With a float, it's essentially short for floating point number. It's short. It's basically to hold smaller sort of decimal points than say a double. You tend to hold higher number of significant figures in a double than say a float. So moving on to a double. So if I say let C equal is a double, and that's going to be like 0.567 blah blah blah. So yeah, there's not really much difference other than the fact that a double can hold more significant figures than a float. So more often than not, you would just use a double. In fact, Swift will infer is a double if you just use a point. So if you don't actually explicitly cast it, Swift is just going to infer that C is a double and not a float. Same with float. If I got rid of casting it as a float, it's just going to infer is a double and not a float. Just because it's double, you get more flexibility with the number of significant figures you can have in the decimal. So moving on to a Boolean, essentially it's just a true or false statement. So if I say it's a bool, it has to say it can only be one of two things. It can either be true or false. That's pretty much all it is. It has a lot of applications though, like as simple as it sounds. In the real world, when designing, say, an app, if you want either a switch that's either on or off, then obviously the bool is the obvious choice there. So it's either a 1 or a 0 in binary. Again, something to note as well, moving on from something to add to Swift inference. Swift will infer a lot of data types, especially the basic data types. It's just going to know off by heart exactly what you imply. So a lot of the time you actually don't need to explicitly cast a constant or a variable, because Swift will automatically infer based on what you put as the value, what that is. So obviously if you put false, it's obviously going to be a bool, so Swift's going to infer that as an integer. if you don't have a decimal point after it, it's just going to infer that's an int. But if you do want to explicitly say what type the constant or variable is, you can. Moving on to string. String is essentially just a collection of characters, i.e., well, a string of characters. So again, I'll just explicitly say it. So it can be a name, too long, or like anything like that. Could be anything. George, or anything like that. So it's essentially just a collection of characters. I think that's how it's displayed. That's how it's defined at a lower level. It's just an array of characters. But Swift has a string data type built into it, so you don't actually need to explicitly make a string like I believe it's C. You have to actually make it an array of characters. The string isn't available. As far as I know, I could be completely wrong. But yeah, it's essentially a string. It's just pretty much, you can have sentences as well. But yeah, it's essentially a collection of characters for that. And then the character is essentially just a single character, like it says on the tin. So character equals, you essentially just, so for a character, you essentially just, it's just going to be one character. So you can't then put a second character, otherwise it's going to get confused. It just needs to be one letter, or alphanumeric letter. So it could be any single digit or any single letter. And that's pretty much all it is. It can't be any more, otherwise it's going to complain. So you can't have like YH. It's just not going to like that. In that case, it would need to be a string. In fact, I think Swift won't infer characters. Sorry, I won't cast it. So I say E or R, sorry, completely. It's not going to infer, I think it's going to infer as a string. Yeah, so that's another thing to notice. Is that for character, if you want something to explicitly be a character, you will need to explicitly call or say it's a character. Otherwise, it's just going to infer as a string, even if it's a single letter or number in the quotation marks. Okay, so optional, as far as I know, is actually exclusive to Swift, and all it really means is that all these data types so far have them, as far as Swift's concerned and compiler is concerned, always have to have a value. So let me explain. So if I say let G, say is it H after? I don't know. But say if string with question mark, which denotes the optional, equals nil, and what nil means is literally just the absence of a value. It's got nothing there. So you wouldn't be able to do this if it wasn't optional. So if it didn't make it optional, if it make it a regular string, it's going to complain because it's not an optional. An optional basically just means it can contain no value whatsoever, which is nil. And also not to be confused, because when I first started out, I was confused. Nil isn't the same as zero, because zero is still a number, it's still a value. However, nil is just complete absence of a value. The optional only denotes that it could be a nil value, so it could contain an integer, for example here. As an optional integer, it could just contain a regular integer, or it can contain nil. That's the main difference between an optional integer and a regular integer, or any other type of data type for that matter. That could be an optional string. All the optional says is that it could contain nil, but it could contain an expected value, i.e. a string or an int, or any other data type for that matter. Same with floats and doubles. Without going too much into detail of optionals being used in applications, they're basically it's useful to just denote if you're calling a kind of API from the web, some of the data might not be there, so you might want to make things optional so that the app won't crash if it's expecting a value when it doesn't get anything, essentially. I will go into optional unwrapping in another video to safely unwrap an optional, because if you don't unwrap an optional, an application is going to crash. Because if the computer expects a value and it doesn't get one, it gets nil, it's going to crash. It's just it's not going to know what to do with it. But yeah, that's pretty much wraps that up for this video. As I said, I'll go into optional unwrapping in a different video, but that's basically an introduction to Swift data types. I hope you found that helpful, and if you did, please subscribe. Alright, see ya.